Hello everyone. In this video, we are going to talk about section 8.7, which is about eigenvalue and eigenvector. As the first question here, two vectors as letter A is given to us, as the red ones that you see here. We are going to describe how multiplication affects by a matrix on this letter L. For the first one, as you see here, A is negative 1, 0, 0, and 1. And if we want to find the affection of this, we would multiply it by U. So we can pick that here as negative 1, 0, 0, 1 for matrix A times the first vector as 0, 2, because otherwise it cannot be multiplied. So it will be 0 and 2. So it seems that nothing changes here. But for the second one, if we call it V and we multiply them together, we would have 1, 0 here. And if you apply this, you would have negative 1 and 0. So in here, it seems that something changed. If you pay more attention, we would see that the component as 2 for the first one and 0 for the second one doesn't change, and it remains the same. But the x component changes, and in here, that would be the opposite of the original one. So for the first one, it was 0 and it remains 0, but for the second one, it was 1 here and it became negative 1. And this is called reflection. So as you see here, the red one is letter A that is given to us. Let's see what are the new ones. For the first vector, nothing changes. So this will be the first one as we have here. And for the second one, that would be negative 1 and 0. So this will be the second one as we have here. So comparing the red L and the blue L, we would see that it is reflected about y-axis. So this matrix is a matrix that is about reflection about y-axis. Same idea for part B. If we find A times U, it will be the multiplication of this matrix and 0, 2 as the first vector, and that would be 0 and 2. The second one is V. It will be 1, 0, negative 1, 1 multiplied by 1, 0. And if we multiply them together, we would get 1 and negative 1. So comparing the new vectors with the previous ones, we would see that x component for the first one and the second one doesn't change, but the y component changes somehow. With comparing them, we would get that the y component decreases by the size of x component. As for the first one, it is 2 minus 0, and for the second one, it is 0 minus 1, so it will be negative 1 here. And it's about shears, or you would see that it is the rotation of clockwise and increase in length. So we have the red letter A. Let's see what is the new one. So if we want to draw the new ones of part B, the first one remains the same, which is this one. And the second one, which is 1, negative 1, will be something like this. So the new ones are shears of this first one. Part C is going to be a times u, which is 1001 over 3 times 0 and 2, and the answer would be 0 and 2 over 3. If we do this for v, that would be 101, 0 and 1 over 3 times 1 and 0. And the answer will be 1 and 0. So this one, we expect to have contraction or expansion. Comparing these two, we would see that the exponent doesn't change, but the y component will be divided by 3. And for the second one, we can say so because 1 doesn't change, but 0 can be divided by 3 and we would get 0. So in here, x component remains the same and y component will be divided by 3. Actually, it will be decreased. So the factor for this will be 1 over 3 and this would be a contraction. And the contraction is vertically because we know what the red one is something like this. But in here, if this is 1, 0 and 2/3 can be something like this. And 1, 0 can be something like this. So if we see that in the same scale, we would see that this length is less than this one. So it will be contraction by factor 1 over 3 and not expansion. Next one is D. And for this one, it will be a long one. It's called rotation. So we know that for rotations, sometimes we expect that maybe if it is mixed with other translations, that would be difference in length and it will have difference in angles, but it depends. So for here, we're going to say that they don't change because we are going to have a kind of rotation that doesn't affect the length and angles. So let's see what happens here. Okay, so let's say we're going to multiply a and u, and for this one, we can say that it's something like s. So it will be square root of 3, 1 over 2, this is divided by 2, negative 1 over 2, and square root of 3 over 2, times v, which is 0 and 2. And the answer will be negative square root of 3 and 1. Okay, let's keep this here. And the next one, which is a times v, let's call it t. It will be square root of 3 over 2, negative 1 over 2, 1 over 2, square root of 3 over 2, times 1 over 1 and 0. And this will be 1 over 2 and square root of 3 over 2. So we need to find the length of these two. The length of s, or a times u, will be square root of negative square root of 3 squared plus 1 squared. That would be square root of 4, so it will be 2, which is the same as the length of u, because that was square root of 0 squared and 2 squared, which is the same as square root of 4, which is 2. Also, for the length of t, this will be 1 over 2 squared plus square root of 3 over 2 squared. And this one will be square root of 1, which is, of course, 1. And this is the same as length of v, which was 1 squared plus 0 squared. So length of the new ones is the same as the old ones. Let's talk about the angles. So let me erase these and continue with finding the angles. For first one, we're going to find the cosine because cosine helps us to find the angle of S and U. That would be S times U over the length of them multiplied together. It means that we would have negative square root of 3 and 1 times 0 and 2 over 2 times 2. So if we multiply them together, for the top will be 2, this one is 4, and we would simplify it as 1 over 2. So we know that theta here is the cosine inverse of 1 over 2, which is pi over 3. And this theta is the angle between S and U. Same thing for the next one. So cosine of theta between t and nu will be t times nu over the length of them, which will be 1 over 2 and square root of 3 over 2 times 1 and 0 over the length of them, which is 1 over 2 over 1, which will be 1 over 2. So that would be theta here, which is cosine inverse between t and nu of 1 over 2, and this one will be pi over 3 as well. So we see that both new vectors have the same magnitude as their original vectors, but they are rotated counterclockwise by pi over 3 or 60 degrees. Number 2, okay. For number 2, we would determine whether or not the given scalar k is an eigenvalue of the matrix A. So we know how to find the determinant of 3 by 3 matrix. We would repeat the first column and the second column here, and we are going to find the determinant of A minus lambda I, which will be multiplication of all these, which is 0, plus all these, plus these, minus these ones, and also these ones. Okay, something is wrong here. These are like this, which is 0. These are like this, which is 0. And these ones, which is 4. Altogether, it will be 0. So since the determinant of A minus lambda I, based on the question k or the eigenvalue, which we call lambda usually, will be 0. So the question is, if we put the eigenvalue as 0, which will be A, is it correct that would be 0? The answer is yes. So since this is a correct equation, so k equals 0 is an eigenvalue. Part B, same idea here. Determinant of A minus lambda or the eigenvalue, which in this question, it will be 2. So it means that we are going to find the determinant of 5, 2, 0, 1 minus 2, 0, 0, 2, which is the determinant of 5 minus 2, which is 3, 2, 0, and -1 here. We know that if we want to find the determinant of this one, will be 3 times -1 minus 0, which is -3. And of course, this one is not 0. So since this determinant is not 0 when we assume that the eigenvalue is 2, so it is not a correct eigenvalue. Number 3. Find the eigenvalues and eigenvectors of each matrix. For the first one, so we would say, let me write it here. We're going to find determinant of A minus lambda I. We know that when we do this, the diagonal will be subtracted by lambda. So it will be the determinant of 1 minus lambda, 2, 3, 0, 1 minus lambda, 7, 0, 2, and 1 minus lambda. In order to find a determinant of a 3 by 3 matrix, one of the ways is writing the first column here and the second column. Then we are going to find determinant of A minus lambda I by subtracting 2 parentheses. For the first one, it will be multiplication of these, which is 1 minus lambda cubed plus 0 plus 0. And the next ones are these, which will be 0 for the first ones. For the second ones, it will be 14 times 1 minus lambda. And the last one is 0. So if we multiply them and then simplify, we would get 1 minus lambda cubed minus 14 times 1 minus lambda, which we want to be 0. So you can put them equal and move the 14 times 1 minus lambda to the other side, or you can factor out 1 minus lambda. And from the first one, we would have 1 minus lambda squared and -14 from the second one. So either the first one is 0, it means lambda is 1, or the second one here is 0. It means that 1 minus lambda squared will be 14. And from here we have two answers. Lambda can be 1 minus lambda can be plus or minus square root of 14. And from here, lambda will be 1 plus or minus square root of 14. So as you see, the given matrix was a matrix of size 3, and we ended up having 3 eigenvalues. Excuse me. These are counted as 2. For each eigenvalue, we're going to find the eigenvector. Let me erase all these and start with if lambda is 1. If lambda is 1, we would put, okay, let me write that again here. It was 1 minus lambda, 2, 3, 0, 1 minus lambda, 7, and 0, 2, 1 minus lambda. We would plug in lambda as 1, and we would get 0, 2, 3, 0, 0, 7, 0, 2, 0 times v sub 1, v sub 2, v sub 3 equals 0, 0, 0 here. From this one, if you would like to write the system of equations, we would multiply the left parts, and that would be 2v sub 2 plus 3v sub 3 equals 0. Also, we would have 7v sub 3 equals 0, and 2v sub 2 equals 0. Of course, from the second one, we would have v sub 3 equals 0, and from here, we would have v sub 2 equals 0. But what about v sub 1? There is no obligation for v sub 1. We call it a free component. So v sub 1 will be a free component. It means that you can pick any number for v sub 1. You can pick a general number like alpha, beta, or something. Or you can say that I would like to pick v sub 1 as, let's say, 1. And we know that v sub 2 is 0, v sub 3 is 0. So a typical eigenvector here will be 1, 0, 0. And if you pick v sub 1 as, let's say, 5, this would be 5, 0, 0. And that would be correct as well. Same process for the next eigenvalue. So we would change these and all these. This time, lambda will be 1 plus the square root of 14. So plugging in 1 plus the square root of 14, we would get negative square root of 14 for these entries. And if we multiply them together, the equations will be negative square root of 14 times v1 and 2 times v2 and 3 times v sub 3 equals 0. Also, we would have negative square root of 14 v sub 2 plus 7 v sub 3 equals 0. And for the last one, we would have 2 times v sub 2 minus the square root of 14 v sub 3 equals 0. If we solve them either from the first one or the second one, you would say that there is a relation between v sub 2 and v sub 3. So if we would pick one of them, let's say we pick the second one. From here, if you would like to find v sub 3 in terms of v sub 2, it's enough to write v sub 3 equals square root of 14 v sub 2. And from here, v sub 3 will be square root of 14 over 7 v sub 2. But if you pick the last one, that would be something else, but you need to multiply it by conjugate, and after simplification, you would end up the same equation. So they are related to each other with this coefficient. So it depends what we pick for v sub 2, and from that we are going to calculate v sub 3. So we pick, let's say if we pick v sub 2, a number that can be simplified, let's say 7. You can pick any other number. From here, we conclude that if we pick 7 for v sub 2, then v sub 3 will be square root of 14. But what about v sub 1? According to the first one, negative square root of 14 v sub 1 will be negative 2 v sub 2 minus 3 v sub 3. We can multiply both sides by a negative, so it is correct if we write it as all positive numbers here. And since we assume that v sub 2 will be 7 and v sub 3 will be square root of 14, so we would have square root of 14 times v sub 1 equals 14 plus 3 square root of 14. And from here, if you divide both sides by 14, you would have v sub 1 as 14 plus 3 square root of 14 divided by square root of 14. And also you can multiply this by a conjugate. So from here, v can be written as 14 plus 3 square root of 14 over square root of 14. And the next one 7, and the next one square root of 14. Let's say we're going to find it for lambda equals 1 minus square root of 14. So we would change this part and all these parts. If we plug in 1 minus 14, of course, this square root of 14, we would have square root of 14 here, also here, and also here. If we multiply them together, we would have square root of 14 times v sub 1 plus 2 v sub 2 plus 3 v sub 3 equals 0. And the next one, square root of 14 v sub 2 plus 7 v sub 3 equals 0. And the last one, 2 square root of 2 plus square root of 14 v sub 3 equals 0. With the same process that we taught for 1 plus square root of 14, we would have v sub 3 as negative square root of 14 over 7 times v sub 2, and v sub 2, we can assume that at negative 7. So from this, v sub 3 will be square root of 14. And based on all these, v sub 1 will be as negative 2 times square root of 2 minus 3 square root of 3 over square root of 14. And if you multiply this by conjugate, that would be something else. But from all these, v can be written as this fraction as the first one, and the second one as negative 7, and the third one as square root of 14. This is the eigenvalue related to, this is the eigenvector related to the eigenvalue 1 minus the square root of 14. Let's do next one, which is part B of the same question. This is a 2 by 2 matrix. For this one, we would say the determinant of A minus lambda I will be the determinant of 1 minus lambda, 2, 2, 1 minus lambda. And this will be 1 minus lambda squared minus 4 equals 0. it means that 1 minus lambda squared is equal to 4, and 1 minus lambda can be either positive or negative 2. From this, lambda can be either negative or 3. Let's say lambda is 3. From here, the matrix will be negative 2, 2, and 2, negative 2. And multiplying by v sub 1 by v sub 2 equals 0, 0. And from this, it will be negative 2 times v sub 1 plus 2 v sub 2, which is 0. And the second one, which will be 2 v sub 1 minus 2 v sub 2, is going to be 0. If you pay attention, we would get that the first one and the second one, these two equations are actually the same, and one of them is the opposite of the other one. So it means that v sub 1 will be equal to v sub 2, either you pick the first one or the second one. So it's enough if you assume that v sub 1 is just a number like 1 or any other number that you would like. And from this, v will be a vector, which the first one and the second one are the same. So let's say you picked 5 here, v would be 5 and 5. Now, for the next part, if lambda is 1, negative 1, it will be 2, 2, 2, 2. And obviously, they are the same. So from this one, the equations will be 2v sub 1 plus 2v sub 2 equals 0. And also the next one, 2v sub 1 plus 2v sub 2 equals to c. So either the first one or the second one, v sub 1 will be negative v sub 2. And you know that these are the same but the opposite. So we can be any number that are positive, that are opposite each other. The first one can be 1, the second one can be negative 1. Or you can pick this first one as negative 5, the second one would be positive 5. So this is the eigenvector related to the eigenvalue negative 1. Next question is number 4. Please read it and then listen to the solution. So we're going to find a minus lambda I here and the determinant of that. So that would be 1 minus lambda 0, 0, and negative 1 minus lambda, which will be 1 minus lambda times negative 1 minus lambda equals 0. So we can say that the second one is negative 1 plus lambda. And also the first one is 1 minus lambda. So if we set them equal to 0, it can be either the first one be 0, so lambda would be negative 1, and or this part will be 0. It means that lambda is negative 1. So we have two eigenvalues. If we pick lambda as 1, the matrix would be 0, 0, 0, negative 2. Multiplied by v sub 1, v sub 2 equals to 0 and 0. So multiplying them together, we would have 0 equals 0 for the first one, and negative 2 v sub 2 equals 0 for the second one. So it means that v sub 2 is 0. But what about v sub 1? Since this is an expression which is always true, So there is no obligation for v sub 1. We can pick v sub 1 any number, but we can pick it 1 as well. So v in here can be 1, but v sub 2 should be 0. Same idea when you pick lambda as negative 1. So if lambda is negative 1, what is the difference? If lambda is negative 1, the matrix would be 2, 0, 0, 0. And the equations are 2v sub 1 equals 0, 0 is equal to 0, so this is always true. And the second one is v sub 1 equals 0. So if we pick v sub 2 as a number, like 1, v would be 0, and this is the eigenvector related to the eigenvalue.